friends, welcome to the channel. My name is Abigail Tan, and in today's video we're going to be going over something called the homologous series. Let's get down to it. The homologous series is just another way for chemists to organize the compounds, organic compounds, into different groups. So that means that each group will have their own specific feature, kind of like how in school you will have your jocks, your nerds, whatever cliques we have these days. And depending on, let's say if you say he's a jock, then you would expect he's going to be sporty, he might be buff, he might be strong, fast, etc. Whereas if someone is a nerd, you would expect he or she to be smart, academically doing well, etc, etc, etc. In chemistry, a homologous series will always have these 5 features. Every homologous series, whether it's the alkanes, the alkenes, alcohols, etc., they will all have certain features. And these features include things like they have the same functional group, they have the same general formula, they have similar chemical properties, they have a trend in physical properties, and then they also have consecutive members differing by CH2. Let's use alkenes as an example. So if I have a look at your alkenes will have a CC double bond. So long as you see a CC double bond, it's a good chance that it's going to be an alkene. If you see that there's a general formula, the number of carbons to hydrogens there are, it's a 2-to-1 ratio. So for example, C2H4, C3H6, C4H8, all of those are some sort of alkene because for every 1 carbon, there's double the number of hydrogens. So if we then look at your similar chemical properties, every single alkene will always react with the bromine water. If we then have a look at the last feature in your homologous series, it is that consecutive members differ by CH2. So if we compare the first 3 members of your alkenes, you have your C2H4, C3H6, and then C4H8. So if you have a look to go from C2H4 to C3H6, I literally added 1 carbon and an additional 2 hydrogens so that I can go from C2H4 to C3H6. And same thing if I wanted to go from C3H6 to C4H8. I have to add 1 extra carbon and 2 extra hydrogens. That is what they mean by consecutive members differ by CH2. A word of warning though, when you give these features, generally speaking, do not use similar physical properties or a trend in chemical properties. You will not get the mark in the exam if you do so. Let's have a look at some examples of some homologous series. You have your alkanes. Alkanes generally, it's all single bonds, it's saturated as a compound, and they only comprise of carbon and hydrogen. Alkenes, very similar to your alkanes, except they have that CC double bond. Then you have your alcohols, pretty much saturated again, all the carbons have all single bonds, but then you have an OH group there in at least one of the carbons. Then carboxylic acids, you have your COOH. Then your esters, they will have the COO group. And then you will have your halogens. The X there that I put there is just for the sake of telling you that it can be any sort of halogens, such as fluorine, chlorine, bromine, and iodine. Okay, and there's a bunch more, like if you're in higher levels, like IB, like you have your alkynes, amine, amide, etc, etc. I won't go into them in more detail in this video, just because it will become way too long if I do. Let's have a look at some examples just so we can have a better understanding of what we're dealing with. So here are 3 examples of molecules, and let's say I have the first molecule here, which contains 4 carbons. So because it contains 4 carbons, then we know we can have a look. So 1 carbon will be meth, 2 carbon will be eth, 3 is prop, 4 is bute. So we're dealing with a bute here. And then because there's also that OH group there, then we know that for sure it's going to be some sort of alcohol group. So it's butane, butanol. If you're in GCSE, writing butanol is good enough. However, if you're in IB, then you need to actually write down the position of the OH group. So how do you know what's the position of the OH group, as in the number that you put into it? You always want to write down the smallest number possible for the OH group, because that is the functional group. So in this particular case, you have 1, 2, 3, 4. or 1, 2, 3, 4. And if I have a look at these, the carbon with the OH group, the smallest possible number of that carbon is 2. So therefore, this is actually butane 2-ol. So now let's have a look at the second molecule. So in this particular case, we have 1, 2, 3, 4, 5 carbon in the longest carbon chain. So then that means that this particular molecule should have, so again, let's do it again. So meth, eth, prop, but, pent. So in this case, it has to be pent. And then if we look for the functional group, it has that CC double bond, meaning that chances are this is going to be an alkene. So name-wise, it's probably a pentene. Again, at GCSE, this is good enough. However, at IB, you do need to write down the position of the CC double bond. In this case, if we have a look at the smallest number that the carbon with a double bond can be found, it's number 2. So if I do 1, 2, 3, 4, or 1, 2, 3, 4, 5, then we can see that the smallest number possible, it's actually 2. So therefore, this is pentuene. So let's have a look at this last group. This is a bonus one here. So you have here your COO group. This shows us that this molecule is most likely an ester. So what you need to do when it comes to the naming, you need to look for the carbon that is attached to the CO single bond first. That is the carbon that will be attached to the alcohol that was attached to the alcohol group. As a result, that is going to be named first. That one has particularly 1 carbon, meaning it's going to be methyl. Then the second part of the name for your esters, you need to look at the carbon that's got the CO double bond. That one is the one that's going to be attached to the carboxylic acid group that was used to make the ester. So then, and that one has 1, 2, 3 carbons attached to it, meaning this is going to be a propene. With your esters, it's going to be something yl, something O8. So in this case, there's 1 carbon for the alcohol group, so it is methyl. And then when it comes to the carboxylic acid part, it is your propanoate. Lastly, we're going to look at how the different homologous series all connect. So kind of like how a jock could become a nerd, or a nerd could become a musical geek. Any of these homologous series can actually turn into other homologous series. Now, they are not all going to be able to turn into every single one, but there will be certain reactions that can help us go from one homologous series to another, and potentially even another. So generally, you will need to know your alkanes will be able to turn into your halogenoalkanes, and your alkenes can then turn into your alkanes, halogenoalkanes, and your alcohols. On top of that, your halogenoalkanes could also become your alcohols, and that alcohol could technically then turn into a carboxylic acid, and both the alcohol and the carboxylic acid that you just made could then be used to create your ester. I know this is one of the most confusing parts of organic chemistry. We could just go through every single reaction in future videos. I hope you liked this video. If you did, hit the subscribe button or hit the like button, and if you have any comments or requests, leave them in the description box below, and I'll see you in the next video. Thank you for watching. Bye.